Welcome to The Explainer. Today, we're digging into the secret engine that powers artificial intelligence. And that engine is math. We're going to use Andrew Hinton's Basic Math for AI as our guide to build a quick start for understanding the language that actually lets machines think and learn.
Our source kicks things off with this really profound quote from Galileo. It's a great reminder that to understand something as complex as the universe, or, to build an artificial mind, you first have to speak its language. And for AI, that language is 100% mathematics.
So that brings us to the big question, right? We're always hearing about these complex algorithms and neural networks, but what's really going on underneath the hood? Why is simple, old-school math the true backbone of it all? Let's break it down.
You see, at its heart, AI is all about learning from data. And math is the language that makes that learning process possible. It's what allows a machine to measure, to interpret, and ultimately to make decisions about the world around.
The source gives us this fantastic analogy that just makes it all click. Trying to build AI without math is like trying to write a book without knowing your ABCs. It's impossible. The letters are the absolute basic building blocks for words, sentences, and entire stories. And in the exact same way, math provides the essential pieces for building AI.
So what's in this AI alphabet then? What do you actually need to know? Our source boils it down to an essential toolkit, 4 mathematical pillars that you'll find supporting pretty much every AI system out there.
First on our list is algebra. You probably remember this one from school, all that time spent solving for x. Well, in AI, that's incredibly important. Think of algebra as a kind of treasure hunt, where x is the treasure. It's the tool that helps us design algorithms that can find those unknown values and solve really tricky problems.
And the way to think about it is like a perfectly balanced scale. To figure out that unknown weight, x, you have to keep the scale perfectly level. So whatever you add or take away from one side, you have to do the exact same thing to the other. That simple idea is the key to how algorithms can zero in on variables and find the answer.
All right, our next pillar is calculus. Now, if algebra is about finding things that are static, calculus is all about a world in constant motion. AI models are always learning, always improving, and calculus is the tool we use to measure, guide, and fine-tune that whole process of change.
Calculus is really 2 sides of the same coin. On one side, you have differential calculus. It's like putting a system under a microscope to see how fast it's changing at one single tiny point in time. On the other side, you have integral calculus, which does the opposite. It's about adding things up, like finding the total area underneath that curve. One breaks things down, the other builds them up.
Our third pillar, linear algebra. Honestly, this one is a total game changer for modern AI. People often call it the language of data, and for good reason. It gives us the toolkit to organize and play with the gigantic datasets that AI models need to eat for breakfast.
So how does it do that? Well, it uses these things called vectors and matrices. Just think of a vector as a neat list of numbers, and a matrix as a grid of numbers, like a spreadsheet. A whole photograph can be represented as a giant matrix of pixel values. Your movie preferences? That can be a vector. Linear algebra gives us the rules to handle all that data efficiently.
And that brings us to our final pillar, probability and statistics. Because, let's face it, the real world is messy. It's not neat and tidy, it is full of uncertainty. So AI needs a way to deal with that. And these two are the go-to tools for making smart decisions when you don't have all the facts, which, let's be honest, is pretty much all the time.
Now, they're like 2 members of the same team, but they have different jobs. Statistics helps us look backwards, sifting through data we already have to find important patterns. Probability, on the other hand, helps us look forward, to figure out how likely it is that something will happen. You put them together, and you give an AI the power to reason about a very uncertain world.
Okay, so we've got our 4 pillars: algebra, calculus, linear algebra, and stats. Now for the fun part. Let's see how this theory gets put to work in the real world, in stuff you probably use every single day.
This is the billion-dollar question, isn't it? How does a machine actually get smarter? Well, when we train an AI model, it makes a guess, and that guess usually has some error. The entire goal of training is to make that error as small as possible. But how do you find the bottom of the error?
The answer, more often than not, is an algorithm called gradient descent. It's pure calculus in action. Imagine you're standing on a foggy mountainside and you need to get to the lowest point in the valley. What do? First, you feel the ground right where you're standing to find which way is steepest downhill. That's the gradient. Second, you take one confident step in that direction. And third, you just repeat that process. Feel the slope, take a step, over and over until you reach the very bottom. That is exactly how an AI model learns to get better.
And you can see these pillars everywhere. That recommendation engine suggesting your next favorite movie, that's statistics predicting your taste. A self-driving car detecting the edge of a road in a picture, it's using derivatives from calculus. And the huge neural networks powering it all, they're using linear algebra to keep all that data straight. See? It's all connected.
So what's next on the horizon? Because this partnership between math and AI is really just getting warmed up. Let's take a quick peek at the next frontier.
We're already seeing these new frontiers emerge. Things like game theory are helping AI make strategic choices, like in negotiations. Quantum computing is on the way, and it's going to need a whole new kind of math to unlock its power. And maybe most importantly, people are developing mathematical frameworks to literally build fairness and accountability right into the code itself.
And that last point brings up something absolutely crucial from our source. Math itself might be objective and pure, but the models we build with it, they are a reflection of human choices. What data did we feed it? What outcome did we tell it to aim for? It means these algorithms can and do inherit the biases and values of the people who made.
So that leaves us with this final, huge question. There's no doubt that math gives AI its incredible power, but with that power comes a massive responsibility. The most important question for our future isn't just what can we build with this, but how do we make sure that power is used wisely? Thanks for joining us on The Explainer.